So what we're going to do today is we're going to look at solving rational equations, but also inequalities, because we know how to do that a little bit. So I want to solve the equation 1 over x minus 1 plus 2 over x plus 2 is equal to 0. And we should think about what adding fractions means, right? So we should know that we need a common denominator. So if we do that, we have to multiply both sides of the first equation, of the first expression, by x plus 2, multiply both of the second expression by x minus 1, so that you know from simplifying rational expressions in grade 11. And so that gives us x plus 2 on the left and 2x minus 1 on the right. And we have a denominator of x minus 1 times x plus 2. And that all equals to 0 in this equation. Now notice that I'm using equals 0, but if it's not equal 0, then we just have to take whatever's on that side of the equation to the left, and we need it to equal 0 because that's usually the case, right? Because in the end we want to solve some sort of equation. So if it equals 0, that's going to help us. Okay, so simplifying a little bit more, we get x plus 2 plus 2x minus 2 on top if we just expand and simplify. And then if we collect like terms, we just end up with 3x over x minus 1 times x plus 2 is 0. Now, we have a denominator here. So how do we get rid of a denominator? Well, we can multiply both sides by that denominator, right? And this works out really nicely because on the left side it cancels out, and on the right side we have 0 times x minus 1 times x plus 2. So what we end up with is just 3x equals 0, because 0 times anything is going to be 0. Now we just need to isolate for x, so divide both sides by 3, and we end up with x is 0. Now what we should think about is that 3x equals 0 could be quite a few things. So we should think about the fact that this could be a more complicated polynomial, like a quadratic, a linear, anything like that, but we know how to deal with those. We can use quadratic formula, factor theorem, anything like that. So in this case, it was pretty easy. We just had to isolate x, but we could use quadratic formula or anything to do more complicated ones. So that's solving equations. Now let's look at solving inequalities. So I'm going to use exactly the same function, 1 over x minus 1 plus 2 over x plus 2 is greater than or equal to 0. So first, we can simplify using exactly the same process. So we'll end up right there. But now, if we multiply both the top and the bottom by x minus 1 times x plus 2, we don't know if that's a positive or negative. And remember, if we multiply both sides by a negative, we would have to flip that inequality. Because x is unknown, like for example, if x was negative 2, then negative 2 minus 1 is negative 3, which means I'm multiplying both sides by negative 3. That's a problem. So what we need to do is we're going to make the same chart as before, except now we're going to include where the denominator equals 0 as boundary values. Okay? So that's the plan. We're going to make exactly the same chart, but we're going to include where that denominator is equal to 0 in our boundary values. Okay? So what that means is we're going to start with 3x over x minus 1 times x plus 2, because that's what we had right here. And what we're going to do now is we're going to list our possible boundary points. So you can see from the numerator, we get that x could be 0. And from the denominator, we get that x could be 1 and x could be negative 2. So those are all possible boundary points. So now we can make our little chart. But since things are more complicated in this chart, we're going to have one row for the numerator, one row for the denominator, and then one row for the final function. So in the chart, we have to pick test values. So there they are. And remember, these test values, I'm just picking them as long as they're in the set of values. So to the left of -2, that's -3. This is in between -2 and 0, in between 0 and 1, and after 1. So now we can just start filling it in. If I plug in -3, the numerator is negative, the denominator is positive, and a negative divided by a positive is negative. If I plug in -1, my numerator is negative, my denominator is negative, and so the full function is positive because negative divided by a negative is positive. If I plug in 0.5, I get positive negative, which means negative, and if I plug in 2, I get positive positive, which makes my whole function positive. So that means we can make a conclusion. F of x is greater than or equal to 0 for x values in the set. Now we're looking at these guys and those guys because that's what made f of x greater than or equal to 0. And I'm going to use square brackets because it's inclusive. So we're looking at -2 to 0, that's the first set, and then 1 to infinity, that's the second set. Alright, so that's solving rational equations and inequalities. So please look back at these examples if you need to, and we'll talk about them in class tomorrow.